Hello everyone, it's December the 8th. Didn't had a good sleep last night. Ended up having some stomach issue. Middle of the night. So the whole day feels a little bit lethargic. But we're gonna do this and then we're gonna train. Alright, let's see what we have. Special array. Okay, let's turn off some of these. Alright, array is considered special if every pair of its adjacent elements contains two numbers with different parity. You're given an array of integer nums and a 2D integer matrix query, where for queries is a from and to. Your task is to check that subarray is special or not. Return an array of booleans answer such that answer I is true if nums is special. So parity is even or odd. So basically say if a subarray is special, then every single pair of adjacent elements have different parity. Okay, so first of all, we just change the input. Instead of the numbers, we do parity. Okay, so odd will be 1, even will be 0. So 1, 0, and 0. Sorry, that's the first one. And a query from 0 to 4, 0, 1, 2, 3, 4. That's a false because the last one is not good parity. Okay, second example, 4, 3, 1, 6. Query 0, 1, 2 is false, but 2, 0, 1, 2, 2, 3 is true. Okay, yeah, makes sense. Okay, so what do we want to know? Well, what we want to know is if given a query, is it possible to do, something like prefix thing? Or maybe, exclusive or something like that. So of course, if it's even, right? If the range is even, then we should have like something like this or something like this. Right, it's even. Or odd, we have more zeros and or more ones. So if we do count, yes, if we do count, we will be able to get the number of ones, right? And then we'll get a number of ones in a range, and that's one way to check. But the number does not specify adjacent, right? We have to be adjacent is different. It's not really number, right? It's not really number. And what else can we try? Oh, I do have one idea. 10 to the 5th. Number length is 10 to the 5th. Maybe we can do bit masking. Bit, right? We turn it into a number, right? Because it's 10 to the 5th, so it's 5 bits length. Well, 10 to the 5th is 6 bit, right? 10 to the 5th, it's 100,000, right? That's 6 bit. and oh no, wait, hold on, no, that's not true. It's the length is 10 to the fifth. So you can have 10 to the fifth bits. No, that's not true. No, that is idiotic. Okay, we're not gonna do it that way. Or what we're looking for. So if everybody is this, right? Like if everybody is fine, then any subarray will be fine. Okay. Now it's not fine if we have patches that contains that break this rule, right? So in this case, this is a patch. In this case, this is a patch, right? If we identify the patches, isn't that what we're trying to say is given a query, so is the query overlap the patch, the bad patch, right? Overlap the bad patch. Or not, it's to be more specific, if the query contains at least 2 consecutive in a patch, in a bad patch, because that's exactly what it is, right? When it's bad, it's just a patch. Okay, so here is another thing. If I have multiple, yes, so like your range has to include 2 of them, right? At least 2 of them. So we can go through, just like go this every time that we have, it's the same as before. We include, so we get like a range. So like this is a bad patch, and then I move on, and then like if I have this, now this is another bad patch, right? So we collect these bad patches in an array, maybe, right? And they are sorted based on the starting point, right? We have a start, so it's starting point sorted, and they are not overlapping, right? They will never be overlapping. They will never be overlapping, okay? So now we have a bunch of patches that's bad. So these are the bad patches, right? So we have, I0, J0, I1, J1, okay, IM, JM, right? So we have, these are the bad patches. Now we have queries. We can also sort the queries. Let's just say we sort the queries, right? We sort the queries, and we start with, Q1. No, let's say P1, Q1, P0, Q0, right? So that's the first one, and then P1, Q1, all the way to PK, QK. So that's our K queries. Now for each one of them, right? I'm going for the 2 pointers again. Actually, the way that I'm doing this. So when we sort by the starting point, and we want to know if this overlaps any of these, right? So the ones, hold a second. If I sort by the starting point, maybe I shall sort by the end point here, right? We sort by the end point here. Okay, we sort by this, so sort by the end, and these we say we sort by start. Okay, now we sort by the end point. Now for each one, we want to see if any of this has overlap. So we have a pointer here, we have a pointer here, and if but it's a start end. Like if the end is also Okay, we'll remove everyone. Oh, hold on. We'll remove everyone that is. Yeah, it's an overlapping kind of question. Right, start end, and then we want to see if it overlaps with any of the bad patches. So we check the first one. If the first one has a, because they're on the starting point. Okay, okay. I mean, you probably can, you know, binary search it because there are no overlapping here, right? Everything is no overlapping. So maybe you can binary search for the starting position, right? The starting position, and this will give you an idea where it lands. So like it may be it lands inside, or maybe it lands. Yeah, it's either inside a range or you're outside or in between, right? If it's inside, then you check the end, right? If it's inside, then you check how many, because this is a length is 2, right? So you find from this, you find this and this, right? If this is smaller than this, then yeah, you're bad. If this is larger, then you check the length, right? Or if here, then you check next here. Yeah, there's a way to do it, right? Binary search will work, but I kind of don't want to go there. Okay, I don't want to go there. I want to see if there is a way, you know, that I don't need to binary search because I sort queries. Okay, I sort queries, and then for each query, let's say I sort based on the starting point, and I have this query, I have this query, right? I sort on starting point. It could also be, yeah, I sort them, right? And once I sort them, I can check the one's smaller than me. Okay, the one's smaller than me. Check if it's the end. Okay, maybe the end is smaller than me, then those can be skipped. So we find the first one, which is the end, is larger equal to me, and that's also fine, right? And I move on to the next one, which is like if yeah, we eliminate all the patches that are not overlapping with me or overlapping with just one letter, with one position, right? We eliminate those. Now we add a new one, right? That its endpoint is either like in between. Its endpoint is in between the query, right? So it's like the smallest endpoint that is at least one position more than one position more than this query start. Okay, and we'll check if it's bigger than its end, than the current query's end, then we go. This is a good one. If not, it's a bad one. Then we check the next one, because we sort based on the starting point, right? We check it based on the starting point. That looks like it might work. Okay. Yeah. All I'm trying to do, all I want to do, is to avoid. Okay. Avoid as much as I can binary search, because I don't think we will need binary search. Okay. So we can call std sort queries. Right, we can sort queries as well. Actually, this is wrong, because I should do begin and queries.end. Okay. So second thing is we need a new vector. Right, we need a new vector of int. Actually, you probably don't want a vector. I guess it's fine. I just do vector of vector, and we'll call it bad patches. Okay. Right, and then we say for int I equal to 0, I smaller than nums dot size I plus plus. Okay. So what we want to say is we want if this is equal to the previous, it's equal to the previous. Okay, so actually let's do int bad start, okay, equal to 0, and then we start from 1. Right, we say if nums I, right, if nums I mod 2 equal to nums I minus 1 mod 2, right? So it's just the same, right? If they're the same, then actually we don't do anything. But if they're not the same, right? If they're not the same, then we'll reset bad start will equal to the current I, and we'll put the previous in, right? We'll put the previous in. Now we say if, so we have a new start, right? So this is different from the previous one. So we have the start, and if it's equal, then we just keep moving. We don't move the bad start, when it's bad. Then what we can say is if I minus 1, okay, minus bad start plus 1, which is essentially, I can delete this, right? This is the number of numbers that have the same parity. If it's larger than 1, right? If it's larger than 1, then that's a bad patch. Then we call bad patches dot pushback. How do I do that? Do I just do vector int bad start and I'm minus 1, right? Okay, this shall happen after I finish this. Right, if they are not the same, then we do this. If they're the same, then we just keep going. So once it's done, we have the bad starts, bad patches, and they're already sorted, okay? And then we do the 2-pointer thing, and then we need to get the result, res, okay? And for int I equal to 0, I smaller than queries dot size I plus plus. Okay, so for each query, we already sorted it, and we need j is equal to 0 as well. So we need to, ooh, that's not right. We want to sort based on the, oh, hold a second, that's fine, because the bad patches is already sorted based on ends, because they're not overlapping. So we already, you sort based on start, you are sorting based on end. So that's actually good. So we can say while j is smaller than, bad length, bad patches size. Okay, so j is smaller than bad length and bad patches j. Okay, bad patches j, we're talking about 1 if this is smaller or equal to queries I 0, right? If that's the case, then we call j++. Okay, we call j++. Once we're done, we'll check one more time, right? If j is smaller than so if j is equal to bad length, which means we have go through all bad lengths, or because we basically say the end is boom, right, hits here. So all we need to check is if this one, right, if this one, because we're checking the end, right, the end. If the end is smaller or equal to, then now the first end that's larger than the query start, right? So there's a possibility of overlap, right? Possibility of overlap. And we want to just see if they have overlap, right? So if they do not have overlap, then it's fine. If they have overlap, then it's bad, right? And then the next one will basically do the same thing. So how do we check if they have overlap? If we have j, right, so what we need to see is, how do we check the overlap? So basically there will be two scenarios, right? There will be two scenarios. We have p queued here, and we know j is here, so it's going to be ij, right? That's one scenario, because j must be here, right? So it depends on the I. How do we quickly identify that they have overlap, or like more than 2? So basically in this case, we need to compute j minus p plus 1, right? And if we keep moving, if j is inside, right? J inside, or if we're moving here, if ij is here, so it's actually j minus I plus 1. But with these two can be combined to j minus maximum of I and p plus 1. Now we can keep moving. Now j come here, right? J come here, I is here. So in this case, the overlap is going to be this. So that's just going to be the minimum, right, of j and q. Minimum of j and q minus the maximum of I and p plus 1. Or I can be right here, right? This one can be huge. J can be here, I can be here. In this case, overlap is minimum this, maximum, so maximum will be p. So that's also works. The last case is here. I and j is here. So in this case, j and q minimum will be this, minus maximum I and p will be this. So this will be negative, right? It'll be negative. Or maybe like if I and q are the same, right? If I and q are the same, and this one will be 1, right? And then you keep going, it'll be 0 overlapping. Maybe I can just use this. Yes, I think this one's fine. We just want to see if it's larger than 2. Okay, so if j is equal to or j is not, then what we shall do is we do this minimum, so std minimum of j and q. What's j? Well, we're using different variables here. Oh my god. So it's the bad patch, the end of the bad patch. Okay, end of the bad patch. End of the bad patch. So it would be bad patches j1. That is the end of the bad patch and the end of the current query. So it will be queries I1 minus std max. So there will be bad patches the start, right? This is the bad patch start and the query start. So this and queries I start, right? So we do this and then plus 1. We want this if this is smaller or equal to 1, right? Which means the overlap, right? Overlap. This is a check overlap, right? Overlap. So if the overlap is smaller or equal to 1, or j is, we already exhaust the bad patches. If that's the case, then we say res.pushback. Oopsie doozy, that should be a Boolean value. That should be a Boolean value. So we'll push back true. Otherwise, we'll do pushback false. Right? Does that make sense? Which means if we have overlap, then we'll push back false, right? And now we go for the next one, next query. And for the next query, first thing, we check the bad patches. And by check the bad patches, we eliminate everything that definitely will not be able to have overlap. So we'll stop on the first one that has the potential of having overlap, right? And we do it. And at the end, we'll return res. Okay, I have confidence on this one. Let's just write it out. Man, my fingers are cold. Get all the bad patches which are defined as subarrays of nums whose parodies, whose pairwise, whose adjacent pairwise parodies are identical. The goal is to see, right, if a query range overlap at least 2 numbers in any bad patch. If such overlap exists, the query shall be false. We sort queries by starting time, by starts, right? By start, and then use 2 pointers, right? 2 pointers to go through the bad patches and queries. We first eliminate all the bad patches whose end is smaller or equal, right? Equal to the current query's start, because these patches, these bad patches, right? These bad patches are impossible to have more than 2 overlapping numbers. Then for the first bad patch that has the potential to produce a 2-number overlap, right? We check it, right? We check it, and we check it and report the result, right? Right, report the result. Then we move on to the next one, right? Then we move on to the next query. So overall, I'll say, so sorting, okay, we say m log m, that is the query, okay, plus n, that's to produce the bad patches, and plus m plus n. So I'll do this, right? I'll do this where m is the number of queries. Okay, let's check. All right, the first one is not right. Okay, debug, let's debug. Oh man, I got so excited these days about debugging. All right, what's the nums? Nums is this. Okay, I also have a vector of 2 many stds. Queries. Ooh, queries. I only have one query, 04. All right. Let's see. This is a is array special. Nums and queries. Let's put a. Yep, let's put it here. We'll save it. Oh, we save it first. Ooh, invalid. Wait, hold on. What? Operands of binary expression. You probably cannot do std cout on binary, which is fine. I mean, I don't really need to cout because I'm debugging it, so it doesn't really matter. Okay, so now what I need is where am I? Now what I need is do clang plus and change this to 9. Okay, we build it, then we set a breaking point. We do F5. Do this. Unable to find. Okay, so that's not right. I'll do it again. There we go. This is the one. Okay, now we can debug. F2. Where's bad patches? Can we see bad patches? Bad patches. Oh, we don't have bad patches yet. Wait, what is this? Huh. I think I didn't get any bad patches. See, that is a problem because we do have a bad patch. Right? We do have a bad patch. The last two. Okay, I think I know why. So I reset the bad start, right? Then I go to the last one. Yep, I have to repeat this part. Ooh, that is correct. So it should be nums.size. Screw it. Let's do this. Int n equal to nums.size. Right, and then here we'll call n, and here we'll call n minus 1. Right, that's the index. Hold a second. Because I'm looking at current one, right? So current one is different. So I check the previous and a bad start to see if we need to do, right? And then if it's not, then I'll land on the current, right? Bad start will be this because it's different. And then, right? And then we'll go to the next one, but they're the same. Then we drop out, right? So now we need to know is the end. So it is n minus 1. Minus is plus 1, so actually it just can be this, right? If this is larger than 1, then we'll push back. It's n minus 1. Okay, let's try again. Try it one more time. Looks good. We submit it. We got wrong. That's pretty bad. Okay. False, false, true, true, true. True, false, true, false, true. Oh my god, that's very, very wrong. What the hell? Alright, so we have a 0, 0, 0, 1. Okay, so I have a bad patch is 0, 1, 0, 1, 2. Right, so this is the bad patch. And what we have, the query is 0, 1, because we sorted by the start. 1, 3. 0, 1, 1, 3, 2, 3. Oh! Ugh. 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 I don't like it. I don't like it. Oh my god. I shall put. Oh, okay, this actually doesn't work. Man. No. This is queries.size. Screw it. M equal to queries.size. Alright, so queries.size M. Alright, and then this is M I plus plus. We need to put the pushback I. We need to put the index into it. Okay, we need to push the index into it. And this need to have the size, which is M. Right? We have a size. I go this, blah blah. So this is not pushback, but res queries. Now I'm wondering, why do we even do it that way? Why can't you just go through all the queries? Right? You can just go through all the queries. Because the only time you use I is, so we're going to do auto query, right, of queries. Oh, that's not what I want. Let's go back to this. Auto query of queries. Okay. And this will just be query, all right? And actually all the queries, oh, hold a second. So be query, okay? Next one, do this, okay, query. Okay, so we're gonna do query 0, 1, 2, that's the index. All right, so this is going to be the same. Query 2. Okay. Yeah, I think this one takes a while. A lot of the issue is also because I'm just not very fluent in C++. There you go. Submit. We got it. Every time it's slow. I mean, I don't understand. But we got it. All right, we're gonna read the solution. Binary search, of course. Oh, I think it's prefix sum. Sliding window. I was thinking about prefix sum, but didn't really come up with anything. Okay, prefix sum. How do we do prefix sum? Geez, that was easy. Oh, you can preset the value to false. Okay. Prefix sum, prefix sum. Violate index found. So if value found, I put a 1. You just increment. Otherwise, it's the same. So we have a prefix sum of, how many so far, right? Like at this point, how many the number of violations you have seen so far. Number of violations. And then you're given a range. You can find how many violations are in this range. Oh, okay. Good. Very good. Very, very good. Okay, so yeah, such a simple solution. I don't know. I didn't think about it. I was on this path, but didn't really pay attention to this. The number of, right? It's not the parity itself, but the number of violations. Okay, how about sliding window? Sliding window. How do you do sliding window on this? Okay. Max reach. Compute the max reachable index for each starting index. The max reach. Expand the end as long as adjacent. Okay, so max reach. Then you move to the second one. And will be the maximum of end and the start. Now we try to extend, we cannot extend. So okay, max reach, and then you hit someone, then it's and so we redo. Okay. So you have the max reach for each one. Then you have the max reach. So from each point, right? So each point, you know the max reach. So you just check your start. Does the max reach? Yeah. Does your n is smaller equal to max reach? Ah, good point. Very good solution. All right, I'm gonna implement one of them. I'm gonna implement one of them. Yeah, I just start to feel like I don't go with binary search as much. I think I enjoy 2 pointers more, but this problem definitely requires a different solution. I like the this is the prefix sum solution from the official solution. Right, the ideal is to produce a prefix sum of the number of violative, right? Number of violative numbers in nums all the way to I, right? Then for each query, we check the number of violative numbers in query from query 0 to query 1. Very straightforward indeed. P sum. Not 1. Actually, let's do this. Int n equal to nums.size n minus 1. Okay. If nums I, okay, just do this. And 1 is equal to, it's mod 2, it's fine. Nums I minus 1 mod of 2, right? Then we say p sum I shall equal to p sum I minus 1 plus 1, else p sum I equal to p sum I minus 1. Okay, so when this is done, then we can say std vector int res queries m. False. For I smaller than m, I plus plus queries I 0 and queries I 1. Okay, I have a start and end. Then we just need to check if p sum and minus p sum star minus 1. So if start if start is equal to 0 and p sum and is equal to 0, or this is equal to 0, right? Then we call res I the true. Now return res. Okay. It's actually not good because I forgot this should be boolean value. That's wrong because I forgot. Something overflowed. For 1, this should be n. It didn't show you where? I'm following the same syntax, right? Yeah, false. Maybe this has to be 0. Nope. Okay, that's the same. Start and queries I 0, 1. Huh. Okay, there is one issue, that's for sure. So because for here it says minus start directly, so we're counting the number of bad like inside. I don't know. I have no idea. Which one? Okay. That's not right. That's not right. How p sum is all 0? Hey, hold a second. This is not right. Well, first of all, I need to specify this as 0. But I don't really think this one is the issue. Oh, shoot. I don't understand. Okay. Wait, did I fix that problem here? I did. I fixed that problem. It's okay. We'll do one more time. Yep. All right. So we can do F2. So start at 0 to 4. All right, 0 to 4. So it'll be false. Okay. Yeah, it works. The hell? Undefined behavior. What undefined behavior? It's true that even if it's a 1, it's okay. What in the world? What in the world? Oh, it's a short circuit. This is 0, and it's not. Then we go for here. But why would it pass here? Ah, Yeah, why would it pass here though? It's undefined behavior. So basically I should say not equals 0 and, right? Oof, that's rough. Oh, this is even worse. Everything is false. Okay, I think I didn't understand it very well. Let's see, 4, 3, 3. That's right. So it'll be 0. That's a 0, right? So equals is a 1. So that's a 1. So we want to find 0 to 2. That's a bad because I contain 1. 2 to 3, 0, 1, 2, 2 to 3. I want to see the number inside here. Because the starting point doesn't count. Right, so the starting point doesn't count. Just the remaining, how many I have. Okay. Alright, well. P-sum and minus P-sum start. Don't care about the first number. Only the remaining numbers shall not contain any violative number. Wow. So much faster. Alright, that'll be it. That's a good problem. And requires some thought. Well, I was